All right, so we have the other part of this question. Now, it said the reaction occurs in the presence of acid, which is 2. Now, most reactions that actually occur in the presence of acids, like this, you cannot say to slow down the reaction, basically to catalyze the reaction. Is that okay? So, the correct answer to this question is to catalyze the reaction, which is option B. Is that okay? Now, the product can be used to identify the reactant carbonyl compound because now the product is usually a crystalline solid with sharp melting point. Is that okay? Their characteristics melting point is what is used to identify this product, which is option A. Now, the complete hydrolysis of nitride gives, now when nitrides are hydrolyzed, nitride they are something like this. When they are hydrolyzed, they give a carboxylic acid. So the correct answer is option A. The hydrolysis of nitride gives a carboxylic acid. The characteristics of a reaction of aldehyde and ketone is aldehydes and ketone usually undergo nucleophilic addition reaction, where a nucleophile adds to the carbonyl center like this, right? So they usually undergo nucleophilic addition reaction, which is option C. Which of the compounds listed below has a sweet smell? You have the options. Now, sweet smells are characteristics of esters. All right. The sweet smells are characteristics of esters. Is that okay? They are characteristics of esters. So, which of the this thing do you have there that is actually an ester? Of course, you agree with me that option D is an ester. All right, this is an ester. It has a COO group. This is an ester. This first one is a carboxylic acid. This is acid chloride. This is amines. This is what? Ester. Option D. So ester is the one that have a sweet smell. Now the IUPAC name of the compound whose structure is written here is, the compound that was given was something like this: CH3, C double bond O. Then we have CH double bond CH, CH3. Now, my dear students, if you want to name a compound of this nature, how do you name it? First, you have to number from this side. I will get to this double bond first. So here is 1, here is 2, here is 3, here is 4, here is 5. All right. So the name of this compound would be, how do you name this compound? At position number 4, you have position number 3, you have a double bond because the double bond started at position number 3. All right. So, and total carbon is 5, which is pentane. So you say pent. At position number 3, you have a double bond. So pent 3 in. At position number 2, you have the one group. Pent 3 in 2 one is the name of this compound. All right. So this compound is pent 3 in 2 one. All right. Which is option C. Is that okay? So that is the name of that compound. The next one. Typically, aldehydes are more reactive than ketone because aldehydes has a better leaving group. Aldehydes are less sterically hindered. The CO group of ketone is attached to a more electron donating group. And B and C are correct. Now, the correct answer is B and C are correct. Now, aldehydes are less sterically hindered. Then the CO group of ketone is attached to a more electron donating group. If you look at it, you have something like this. Most ketone, their CO group, they are attached to another alkyl, and this alkyl can donate electron to stabilize the positive charge at this center, because we are taught that this CO bond is partially negative here and partially positive here. Are you getting it? This positivity is what actually causes the reactivity, because this is where nucleophilic attack takes place. But if you have an electron donating group that donates electron to this carbon here, it makes it a little bit stable. It's more like positive means say e no get. And when person no get, you can easily like influence that person, right? You can easily react, can tell that person do this thing and he will do it. But let us say as this thing no too get here, somebody call dey donate to am. And that person when they donate to am now, don dey make am dey stable financially. So it will be very hidden, it will be very difficult for that one to react. And that is the reason why aldehyde um are more reactive than ketone, because for ketone there is somebody supplying or bankrolling him, so it's more stable and it does not easily react. Is that okay? Now the bond CO in aldehyde and ketone, this bond is 90% ionic. The CO bond in aldehydes and ketone is about 90% ionic. All right. Now, the following synthetic compound can be employed to produce carboxylic acid except. What are some of the ways we can produce carboxylic acid? One, oxidation of primary alcohol. Yes, primary alcohols can be oxidized to give us aldehyde. Then further oxidation of this alcohol will give us the carboxylic acid. Oxidation of tertiary alcohol. Tertiary alcohols are not easily oxidized, so this should be the correct answer, because this one is not a method for preparing carboxylic acid, because tertiary alcohol are very difficult to oxidize. Hydrolysis of ester, yes. When esters are hydrolyzed, they give us the corresponding carboxylic acid. Then we have the next one, which is hydrolysis of nitrite. I have explained this one before, that hydrolysis of nitrite actually give us a carboxylic acid. Now, which of the following can be used to convert carboxylic acid to acid chloride? Now we have HCl, we have PCl3, SOBr2, and SOCl. This is supposed to be, SOCl2. Now, this thionyl chloride is the correct answer. Although PCl3 can be used, but the one that is mostly used all the time is thionyl chloride. Something like this. All right, thionyl chloride, more like thiol chloride. Is that okay? So that is that for the answer. The increasing order of reactivity of the derivative of carboxylic acid is as follows. Now, the increasing order of reactivity of derivative of carboxylic acid follows this order. This one is less than this, is less than the ester, less than this, and then less than the acid 100. Are you getting it? It means the carboxylic acid, the react lesser than the amide, which react lesser than the esters, which react lesser than the chloride, which react lesser than the acid 100. However, there are also school of thought that believe that the chloride are more reactive than the acid 100. However, this one is the best way to actually represent it based on the options that are available currently. Now, the next question, question number 40 says, dash gives effervescent with sodium hydrogen carbonate. Now, one of the characteristics tests for carboxylic acid is when carboxylic acid reacts with sodium hydrogen carbonate, it gives CO2 and water as part of the product. And this CO2 is a gas. And you know, gas will always give that effervescence, and that is used to test for the presence of carboxylic acid. So the correct answer to that question is a carboxylic acid. Carboxylic acid gives effervescence with aqueous solution of with aqueous sodium hydrogen carbonate. All right. Now, the next question here, then forget about that structure you have there. Let's just follow the reaction. The next question here, the main product of the reaction between this, what you have is CH3, CH, double bond, C bracket CH3, and then you have 2, and ozone plus ozone, right? in the presence of zinc and water is, now this is what we call ozonolysis. And in ozonolysis, the main product of this reaction is a very simple something. All right. Now, all you need to do for this is divide this into two. If you divide this into two at this position here in ozonolysis, it leads to the formation of aldehydes and ketone, or combination of aldehydes or ketones. All right. So this we give CH3, and then here will be what? CH double bond oxygen. So when you divide, add oxygen to one part, then the other will give C bracket CH3, and then you have supposed to be CH3 2, and then here you have what? C double bond O. Is that okay? Now this is an aldehyde, this is a ketone. So the correct answer to that question is option, which of the option? Option B is the correct answer to that question. Although they are not properly written, but you agree with me that option B is the correct answer to that question. What is option B? CH3, CHO, and option B is the correct answer to that question. All right? That is the most appropriate answer to that question. So that's how to go about a question like this. It's a very simple thing. When you see something like this, just know that they are talking about ozonolysis. Put it at the back of your mind. Know that they are talking about what? Ozonolysis. Is that okay? And ozonolysis usually involves you just bringing the compound of interest out, dividing it into two, add oxygen to one end, and then add oxygen to the other end of the other side. All we needed to do was just to turn it around. So here becomes the CH3 into two places, then CO, double bond, then the oxygen. That makes option B the correct answer. Now, that gives a yellow precipitate with sodium hydroxide and iodine on heating. This is called iodoform test. Now, the iodoform test will give yellow precipitate with methyl ketones. What do I mean by methyl ketone? We are talking about compound that have CH3, C, double bond O. Any compound that has the CH3, C double bond O can give a yellow precipitate to iodoform test. All right. So we have the first one here. The first one, the structure they drew here is actually something like this, option A. I don't follow the ones here. Don't follow the ones when they these ones they I actually use AI to bring out the questions from the snapped one because I don't have time to type. So they could not really appropriate some of the options very well and the structures. So these are chemistry structures. This is the first one we have. We don't have anything like a methyl ketone in this structure. So this will not give a positive result. Is that okay? Then let us look at the next one. The next option you have here is B. B will not say give that is CH3, CH2, C double bond OH. This one cannot also give the correct answer to that question. Is that okay? Then you have CH3. The next one, CH3, CH2, bracket 2, CO. This one will not still give the correct answer because if you arrange this one out, it's going to give us C double bond O. Here is CH3, CH2, CH2, CH3. Cannot give you a methyl ketone. All right. Now let's come to the last one. The last one says you have CH3, CHO. If you bring this one out, it gives you CH3, C double bond OH. Now you see that you have the methyl ketone that we are looking for in this structure. The methyl ketone that we are looking for in this structure. All right. So the methyl ketone is this group here like this. That is the methyl ketone. Oh, sorry. Let me Okay, this group here is our methyl ketone, not just this group, including the C double bond O. Let me rewrite it out again. Sorry about that. Something like this. CH3, C double bond O, H. All right. So these are methyl ketone we are looking at here. This group here is a methyl ketone. All right. And anything that has the CH3CO is capable of what? Is capable of giving a positive this into the iodoform test. Is that okay? So that makes option D the correct answer to that question. A very simple one. All right. Let us see the next one. The next one say, how do I react with solution of silver nitrate in excess ammonium hydroxide to form? Now, an ammoniacal solution of silver nitrate, when they react with aldehyde, they form a silver mirror. They form what, my dear student? A silver mirror. So the correct answer is option C. They form a silver mirror. An ammoniacal solution of silver nitrate in aldehyde form a silver mirror. Ketones are oxidized by chromic acid to give. Ketones are not oxidized by chromic acid. They cannot be oxidized, so there is no reaction that will take place. All right? There will no reaction that will take place. All right? So there's no reaction that will take place. All right? For that. Now let's look at number 25. Predict the major product obtained from the following reaction. I don't think that was the reaction anyway. Now you have the reaction here. Sorry. Let me write. The reaction is something like this. Say predict the major product obtained from the following reaction. The reaction is something like this. CH3, C double bond O. Here is CH2, CH3. Then passing it through ammonia and H2. And you are asked to predict the product of the reaction. What do you think the product of this reaction is? Now, this is what we call oxidative deamination. Oxidative amination, rather. What happens is that this NH2 replace this O oxygen here. Then the product would be something like this: CH3, right? And then you have CH, and then you have what? NH2, and then you have CH2, CH3. You are going to see it as part of the options. All right, let me confirm something quickly. This is like a ketone reacting with ammonia, right? A ketone reacting with ammonia. Is this supposed to be NH2, NH2, or NH3? I have to be very careful because of the just a change here can actually like give a different option entirely. It's actually going to form an imine or not an a hydroxide. But none of the options here is an imine. So, okay, the imine will be hydrogenated to give us this. Are you getting it? It first of all is going to form an imine. Now, when these imine are hydrogenated, they are going to form an amine. So that is the mechanism of that reaction. Do you understand? Most of you don't understand, but just take it as it is. What I'm telling you is that this reaction is going to form an imine first. The imine is something like this first. This first reaction is going to form something like this: CH3, C, double bond, NH. Then you have CH2, CH3. Then when you now add hydrogen to this imine, H2, that is when it will now give you this product here. And this is the answer you are going to see in that option. Is that okay? More like elimination reaction. First of all, you add to that place and then you eliminate. All right, because this is NH3. So remove water from here. If NH3 attached to this position and then you remove water, what are you going to form? H2 from here, oxygen from here, H2O. So the N will now attach to this position. If H2 leaves here, what will be left? NH will be left. Are you getting that? NH attached here? Oxygen will react with the H2 to form water. So in this first step, water will be given off to form an imine. Then this imine, if you now add hydrogen to it, one of the hydrogen, there are two hydrogens here, right? One of them will come here, the other will come here. So you have CH here, here will become NH2, double bond will break, and this will be your answer. So that is the major product of that reaction. You can actually see it in the various, say, option shows various enamine structure, and this is the amine that we got as our answer, and that is option A. If you check the past questions or the question that we are giving, you see that is present in option A. Now, which of the following compound with the same molecular weight will have the highest boiling point? Now, the alkanoic acid of the same molecular weight will always have the highest boiling point because of their extensive hydrogen bonding. Because of their what? Extensive hydrogen bonding. So, butanoic acid, so long they have the same molecular weight, butanoic acid is correct. Now, what statement regarding carboxylate ion is not true? The CO bond is shorter than C double bond O bond. That is true. The carboxylate anion is resonance stabilized. That is true. Then the next one. The negative charge is localized over both oxygen atom. That is true. It can be formed by the reaction of carboxylic acid and alkaline metal. That is also true. So which of them do you think is not true? Oh, none of them here is not true. Everything there is true because carboxylic acid can actually react with sodium metal to form a carboxylate ion. All right. Let's see. Method of preparation. All these on their various method of preparation. Let me see the reactions. Carboxylate acid. Salt formation. If we want to even go with anyone, then we'll go with the one of sodium because it is sodium hydroxide we react with to form the carboxylate ion and not the sodium metal. It is the hydroxide. But let me see if there is any reaction of Okay, so we can go with this one. This one is the one that is most likely not to be correct. All right. Now, the process of refluxing a mixture of alcohol and carboxylic acid with HCl is known as esterification. When carboxylic acid and alcohol react, they form ester, and that process is called esterification. Now, you have 49 to 54. Say use the chemical equation to answer. Forget about this equation there. I will give you my own equation here. Now, the equation that was given to you is something like this. Listen, pay attention. The equation that was given something like this: CH3, then we'll have C double bond O, CH3. This is I, then pass it through I to give us CH3, C, OH, yes, CN, CH3. This is I. And then you have IV, yes, CH3, C, OH, yes, CH2, NH2, CH3. This is your V. And they now ask you, compound I is a ketone. You can see it, it's evident there that compound I, this is a ketone here. All right. As a matter of fact, it's 2-propanone. So compound I is a ketone. This is correct. Which of the following conditions are reagents are necessary to convert I to I? That means to convert this to this. Now you actually need the following to convert that. You need KCm, you need HCl at about 10 degree to 20 degrees Celsius. All right, to convert this to this. And that is part of the option there. See, 10 to 20, 10 to 20, not 10 to 20, which is option C. The general name for compound 3 is, this compound 3 is called a cyanohydrine. Cyanohydrine. It's a cyanohydrine, which is option A. Is that okay? A cyanohydrine. Okay. Now, the next one is that shall require to convert II to IV. Now, II to IV is like reducing the amine group. This is your II, something like this. OH, CCN, CH3. Here's what CH3 to CH3. Here's what OH. Here's CH2, NH2, ECH3. Now, for this thing to take place, you will need lithium aluminum hydride, because that one is the one that can donate 4 hydrogens. Are you getting it? It is a potent hydride donor. Require lithium aluminum hydride that can donate its 4 hydrogen. If you look, total of how many hydrogens are added to this position is 2 plus 2 is 4. Are you getting it now? So it will require lithium aluminum hydride in ether, which is option B. It's a reducing reduction. Are you getting it? The next one is the conversion of III to V is what? A reduction reaction. The cyano group was reduced to an amine. Are you getting it? This group here is an amine. So the cyano group was reduced to what? An amine. I mean, these two groups. Yeah, this one was reduced. Are you getting it? To this. Exactly. So that is that. So the next one, the IUPAC name of the compound V is, what do you think is the IUPAC name of this compound? This is your V. What is the IUPAC name of V? It's very easy. How do you name this compound like this? This is 1, 2, 3. Are you getting it? Of course, the amine group is taking priority, which will be 1, 2. So we have 2 hydroxy, 2 methyl propylamine. Why is it propylamine? Because 1, 2, 3. 2 hydroxy, 2 methyl propylamine. 2 hydroxy. Hydroxy is supposed to come before methyl anyway, but if it, because H comes before M. But if you want to go with the options given to you, so it will be 2 methyl, 2 hydroxy propylamine. 2 methyl, 2 hydroxy propylamine. All right, 2 methyl, 2 hydroxy propylamine, which is option A. Is that okay? Now, the decreasing order of reactivity of carbonyl compound. Decreasing order of reactivity of carbonyl compound. What is the decreasing order of reactivity of carbonyl compound? Decreasing order of reactivity of the carbonyl compound. You have a list of some things here, but the correct order I want to give to you now. The less bulkier it becomes, the more reactive it is. So the correct order is something like this. Double bond O is more reactive than when you add one alkyl group. Is that okay? It's more reactive than when you have 2 alkyl group attached. It's more reactive than when you have 1 phenyl group attached, which is more reactive than when you have 2 phenyl group attached because of steric hindrance. The 2 phenyl group there, they are bulky group. So the more sterically hindered it is, the less reactive it becomes. So that option A there is the correct answer to that question. Is that okay? Like this one now is less bulky. What you have here is hydrogen. Here is an alkyl group. We don't know the length of the alkyl group. So if 2 alkyl group are present, that one is of course bulky. Then this one is a phenyl group. Phenyl group are more bulkier than the every other one you have there. All right. Now the next one is what is the there was one question. There was one question that we didn't write here. The stability of CO group is increased by electron donating group. Are you getting it? The stability is increased by electron donating group. So that question was not written here. All right. So take note. The IUPAC name of the following compound. You have something like this is the compound that was given to you, CH3, CH2, CH, B arrow, C double bond O, CH2, CH3. What do you think is the IUPAC name of this compound? It's a very simple compound, right? So what is the name? This is 1, 2, 3. This is 1, 2, 3. Numbering from this side will be much more easier. Here's 1, 2, 3, 4, 5, 6. So this is 4-bromo, 4-bromo, then 3-hexanone, or 4-bromo hexanone, 3-one, 4-bromo hexanone, 3-one, and that makes option D the correct answer to that question. 4-bromo hexanone, 3-one. Is that okay? Exactly. Let's see the next ones we have here. Okay, they put it here. The stability of CO group is increased by electron donating group. This group is correct. Decreased by electron donating group, no. Increased by electron withdrawing group, no. Decreased by electron withdrawing group. This is also correct. So these ones are correct like this. Are you getting it? But you can choose any one of them that you wish. All right. Aliphatic aldehyde may be distinguished from ketones and aromatic aldehyde using aliphatic aldehyde aliphatic aldehyde may be distinguished from ketones and aromatic aldehyde using A. Hoffman's reagent, B. Ferlin solution, C. Grignard reagent, D. Concentrated H2SO4. What do you think is the correct answer? Now, we usually use the silver mirror test, which is the Hoffman's reagent, to actually do that. So the correct answer is option A. Say use the chemical equation below to answer question 61 to 65. I don't know. Let me check if this equation was properly represented here. Okay. It's almost, but almost cannot kill A. So the proper equation is arrow COO arrow prime. Then we have I. Here is what? I. Then you have arrow C double bond O negative sodium plus IV to give us, then we have dilute acid to give us V. All right. Now, say use this equation. The chemical transformation from I to II is saponification. It requires sodium hydroxide. Is that okay? So that equation is called saponification of esters. The reagent and condition of reaction are required for converting I to III. Is refluxing with aqueous sodium hydroxide. I have written it here. Aqueous sodium hydroxide. All right, saponification. All right, let's see the other part. What is the question here? The byproduct labeled IV is what? What is the byproduct labeled IV? IV is an alcohol. Is that okay? IV is what? An alcohol. So the byproduct labeled IV is an alcohol. R prime OH. So come here, which is option B here. All right, option B, the correct answer. Compound V is what? What is compound V? Now, have you gotten this one like this? What do you think compound V is? When you pass this ester, the sodium salt of the ester through dilute HCl, this sodium will be replaced with hydrogen. So it's going to form a carboxylic acid. Is that okay, my dear students? So the product at that point will be a carboxylic acid, which is option A, RCOOH. The other options might not be really well represented, but option A is very well represented there. The compound I is what? The compound I, they are asking you about compound I. Look at that question. I is what? An ester. Hmm? This is I given to you now. This is the general formula of the ester functional group. So compound I is an ester. All right. So option A, the correct answer. Derivative of carboxylic acid with the general formula. I think that general formula was wrong. The general formula of ROC double bond OZ generally undergo what kind of reaction? They usually undergo nucleophilic addition reaction. Are you getting it? They usually undergo nucleophilic addition reaction. Is that understood? So correct answer is option A. Almost all of them undergo carboxylic acid derivative. They undergo nucleophilic addition reaction. Is that okay? If you check, let me. This disubstituted acid and the rest. They usually undergo nucleophilic reaction. All right. Okay. But this is looking at like nucleophilic substitution reaction though, where the nucleophile replace the leaving group. I think it's substitution reaction. They undergo nucleophilic substitution reaction, not addition. They undergo nucleophilic substitution reaction. Sorry. All right. Nucleophilic substitution reaction, not addition. So option B is correct. Is that okay? Now, the unevitable body odor. The unevitable body odor of goat is due to the exuding of this acid: A. Caproic acid, methanoic acid, acetic acid. B. Caprylic acid, methanoic acid, and acetic acid. C. Caproic acid, caprylic acid, and capric acid. Then D. You have capric acid, methanoic acid, and acetic acid. What do you think is the correct answer? The unevitable, is this supposed to be unevitable? The unevitable. So that is caused by caproic acid, caprylic acid, and capric acid. Option C. What is the IPAC name of the compound? Compound that was given to you is something like this. Let me check to check very well. I know this structure is wrong. Don't mind these ones. You have CH3, CH, OH, CH BRO COOH. So which of them is the correct answer in this one? We have one. If you want to number 1, 2, 3, 4, which is 2-bromo. They didn't give the options. 2-bromo. Then we have 3-hydroxy butanoic acid. So the correct answer is 2-bromo, 3-hydroxy butanoic acid, which is option C. Option C is the correct answer to this question. But the options were not actually named here. The stability of the COO ions is determined by resonance effect, inductive effect, A and B, not conjugative effect. The carboxylic acids react with alkaline metal to liberate what? To liberate hydrogen gas. When acid reacts with metal, they liberate hydrogen gas. Is that okay? They liberate hydrogen gas, which is H2 gas. So I believe that is all for those 70 questions. Thank you very much for your time. We'll see you in the next one.